the solutions to a quadratic equation. Let's stop here. A quadratic equation is any equation where the biggest exponent is a squared. The biggest exponent you have will be a squared. So for example, x squared plus 7x plus 10. This is a quadratic equation, okay? The reason why it's quadratic is because it has this exponent of 2. That makes it quadratic. So the solutions to these quadratic equations are the points at which the function intersects the x-axis. So let me draw you a picture. Before I draw the picture, can you guys on the side of your paper factor this quadratic equation? Ready, go. You guys want two numbers that multiply to 10, but add to 7. That's 5 and 2. 5 times 2 is 10. 5 plus 2 is 7. So we get x plus 5 and x plus 2. Okay? Now, we're going to set each factor equal to 0. So set this factor, x plus 5, equal to 0, and set this factor, x plus 2, equal to 0. When I solve, what is x equal to? And there we go. So those are my solutions. If I were to graph them, look, I have a solution at -5 and a solution at -2. Those become your x-intercepts. Okay? So guys, whenever you're factoring a quadratic, you're actually looking for where the x-intercepts are. Okay? So in this case, what are solutions referred to as? One of them is x-intercepts. What's another word for a solution? Yep, zeros. Do you guys know the other one? Starts with an R. Roots. So guys, sometimes they might say, what are the roots? The answer is -5 and -2. What are the zeros? -5 and -2. They all mean the same thing. You'll see these words used interchangeably. Okay, let's talk about what these will look like. Please, on your paper, sketch what a graph might look like if it has two solutions. Sketch what a graph would look like if it has only one solution and if it has no real solutions. So the name of this unit is called quadratics. So all quadratics have a U shape. This U shape is called a parabola. Okay, so I'm going to use parabolas for this sketch, okay? So here's a sketch that crosses twice. That's two solutions. Here's a sketch that has one solution, one x-intercept. And here's one that doesn't have any x-intercepts, no solutions, because it doesn't touch the x-axis. I saw some of you guys, for this one, you did just a straight line. That also works, but we're not doing linears. This is a linear. This unit, we're going to do quadratics. So they're all going to have this parabola shape. Okay? All right. So let's talk about something called the discriminant. The formula for the discriminant is b squared minus 4ac. That is the formula for the discriminant. Now, if you plug in numbers and you figure out that the discriminant is greater than 0, that means there are two solutions. You'll have two x-intercepts. That means your graph might look something like this, where it crosses twice. So just based off of your discriminant, you can tell how many times or how many solutions you'll have. If your discriminant is 0, that means there is only one solution. So it might look something like this. That means you have one solution. If your discriminant is less than 0, meaning it's negative, if your discriminant is negative, that means you have 0 solutions. And your graph would look something like this. It does not touch. Oh, not that one. Not that one. Those are some examples of what it might look like if it does not have solutions, okay? So let's figure out where we get A, B, and C from. This is the format for a quadratic equation. AX squared plus BX plus C. So looking at this problem, 1 is your A value, 5 is your B value, 4 is your C value. Okay, we're going to use those coefficients and plug it into our discriminant formula. So our discriminant is B squared. That would be 5 squared minus 4 times A times C. So the value of A is 1 and the value of C is 4. Okay, what I like to do is put this in a box. Put those last 3 numbers in a box. 5 squared is 25, and we're going to subtract the number that we get in this box, okay? So guys, 4 times 1 is times another 4. So this box is worth 16. So we're going to subtract it. 25 minus 16 is 9. So let's look at our notes up here. Is 9 greater than 0, equal to 0, or less than 0? Greater. That means we have 2 solutions. Based off of my discriminant, I know that my graph might look something like that. Let's try another example. Let's try number 12. My A value is -3. The B value is 5. Oh, that's my B value. And my C value is -8. So let's plug that into our discriminant formula. The discriminant is B squared. So 5 squared minus 4 times the A value times the C value. Put these last 3 numbers in the box. So 5 squared is 25 minus, we have a minus sign. Now let's calculate what this box is equal to. What is 4 times -3? -12 times a -8. 96, a positive 96. So this is a 96. So what I have now is 25 minus 96, which is -71. So how many solutions will I have? 0, because according to my notes up here, if your discriminant is less than 0, in our case, we got -71. That's less than 0. So that means there are 0 real solutions. Now, if I wanted to figure out what these solutions were, we can always factor. I want you guys to tell me what the solutions are for number 7. That means you would factor this quadratic. So everyone try to tell me what the solutions are. I know I'm going to have 2 because my discriminant is greater than 0. That means I'm going to have 2 answers. So that means when you factor, you're going to get 2 different answers. What are 2 numbers that multiply to 4 and add to 5? Yep, 4 and 1. So that means you'll do x plus 4 times x plus 1, set them both equal to 0, and solve. So guys, what are our solutions? Yep, so that means if I were to graph this, those are my x-intercepts. So if I were to graph this problem, we have an x-intercept at -1, 2, 3, 4, and an x-intercept here. It would look like this. And it has 2 solutions.